Welcome everyone. Today we're going to do something festive. So we're going to have a look at Santa's digital workshop showcase using event-driven AI. So this is a demo that combines Drasi, a continuous intelligence platform, with Microsoft Agent Framework to show how you can build intelligent event-driven systems. By the end, you'll see how to detect patterns in real-time data and have AI agents automatically respond to those patterns using Drasi and Microsoft Agent Framework. So let's take a look. So just a quick intro, my name is Luke Murray, I'm Microsoft Azure MVP, focused on Azure infrastructure and cloud solutions. I work at HSO as the infrastructure security and modern workplace lead. You can find me all over social media on LinkedIn, Blue Sky, X. Always happy to connect and have a chat, so feel free to reach out. So the scenario we're going to look at today, or what we're going to build, is essentially this scenario where Santa needs to process millions of wish list requests from children and behavior updates. So we're going to use a couple of key technologies to enable this. One is Drasi, which will detect the patterns in streaming events. So for example, all our wish list events from children, letters to Santa as an example, will be coming in. Drasi will take a look at that. Then Microsoft Agent Framework will be used to coordinate multiple AI agents working together, and of course using Azure OpenAI and GPT-4o models in order to provide those recommendations. Then we're going to also, along with Drasi, as part of the event change processing system, we're going to be using event hubs to feed that information into Drasi as well. So this pattern works for really any real-time event processing scenario that you may think of, but we've just made it festive for the festive tech calendar today. So let's go into a demo. Right, let's go into the demo. So here we have just a PowerShell script to showcase some of the logic that's happening behind the scenes. So there's a couple of different scenarios we'll go through. One is end-to-end wish list processing. The other is sort of multi-agent collaboration and showing what that looks like. A standard streaming server-side events demo, and then behavior detection between naughty and nice, and then feeding that back to what kind of gifts that you may get, as well as showcasing some of the agent tools that have been built into the platform as well, allowing Microsoft Agent Framework to query Drasi directly, including a custom child test just to make sure that what I'm showing isn't quite made up or fake. So what we're going to do first is just showcase end-to-end processing. So if I select scenario 1, what this will do is this will send wish lists. So for example, we've got demo Alice 123, so that's a child that has a wish list that they want to send to Santa. So they deliver their letter from the north to the North Pole as an example. That will go into Cosmos database. Drasi will pick that up from the Cosmos database change feed as a source, and then it will run a continuous trigger. So once certain criteria is met, it will then trigger as, hey, yep, this criteria meets, now send that off to a reaction. That's when Microsoft Agent Framework will then pick that up, and it will get initialized, and then call, obviously, your GPT-4o running on Azure OpenAI, and then the results will get persisted in a Cosmos database for future reference, as well as broadcasted live Signaler endpoint, so we can see it live in a UI I'll show you later. So let's just start this. So we've got our wish list. So for example, demo Alice 123 wants a board game, an RC car, and a STEM kit for Christmas. She's just sent a wish list request or a letter to Santa. So we get those items and we add those in. And we wait. Once they're added in, Drasi automatically will pick that up from the Cosmos database change feed, continuous query will detect that there's a wish list change, which then triggers a graph update. Microsoft Agent Framework will run those ELF recommendation agents that I just talked about. The agent will then query Drasi again for most up-to-date information like naughty and nice status, for example. And then Agent Framework will then generate some recommendations based on the wish list and based on their current behavior. And then it will persist that data to a Cosmos database for future reference, and also keep the state and broadcast it to SignalR as well. So even though that has taken longer than the timeout that I put in this script, if we do click retry, it should have come back with a response, and it has. So we can see here that the recommendations have been generated. So her wish lists were board game, RC card, and STEM kit. We can see here that the recommendations come through board game, Settlers of Catan, RC cars, STEM kits, telescopes. So Alice will get everything that she wants this Christmas. But we can also see estimated price, for example, as well. And you can also add in some logic around what's in the inventory, for example, that the elves already have to pack up and deliver this Christmas. But you can kind of see this is the main bit of logic that's running the solution, essentially the Azure Agent Framework to bring that generative AI capability, and then Drasi running those continuous queries as well. We'll get into more on how that's set up technically after the demo, but I just wanted to showcase some of this stuff first. So that's the first scenario. The second is multi-agent collaboration. So this one could take a while, so I'm just going to trigger that one off straight away, but essentially it's going to show that we've got multiple different agents at play. So again, Drasi will detect a change in event. A recommendation agent will then query GPT-4o for ideas, and then another agent will just match it to the gifts and then call Drasi as needed for additional live data based naughty and nice status, for example, and their wish list data as well. So we can see here that Drasi has already processed the event that I've sent off, and the behavior elves are at work. So we've got behavior analyst, creative gift elf, and the quality reviewer agents all working in parallel for this request from demo Bob 732. So we will wait for this to complete. Hopefully it's not too much longer. And it's completed. So what we can see here is the demo Bob 723. Its status is nice. It didn't have any wish list items, so we didn't send it anything like we did with the previous example. Top trending items at the moment, however, from Drasi is Lego Star Wars set, Nintendo Switch, PlayStation 5, some books, and remote control cars. So these are things that are picking up from potentially other children. So in this example for demo Bob 732, we didn't send a wish list like we did previously. We've just gone, okay, well, this child is nice, we need some gifts potentially that the elves need to prepare, so then Santa can deliver it to this child. So based on the current active trending gifts at the moment, we can see that Lego Star Wars and PlayStation 5 are on the wish list agenda. From a creative perspective, we can see, oh, actually we can, we've got building blocks, we've got stuffed animals, maybe some picture books. Again, this would take into consideration the age of the child as well. I haven't sent it in this payload, but it is taken into consideration as well. And then we finally do have some recommended gift recommendations. So Lego Star Wars set, Nintendo Switch, and remote control cars. And we can see that it's used the following Microsoft Agent Framework agents, so behavior analyst, so naughty and nice, creative gifts, so like what are the gifts that might suit this child in this gender, this age bracket, for example. and then actually like Santa and elves, what are you smoking? We know that a lot of the current trending items at the moment are these things, so let's pair them together and actually give you a proper recommendation. So we've got all three running side by side, all three agents working alongside the live graph information coming directly from Drasi. So these were the agents and the tools that were called to get this response: get the child behavior history, search the gift inventory. So if we've got our elves in the workshop, what have they already processed or ready to go out? What are the budget constraints that we might have? I mean, I can only imagine that Santa is not rich, and there's a lot of gift giving to give around in festive cheer, and then some query graph as well. So not only is it using generative AI to sort of give us the context, but it's bringing in a lot of live data and wish list analysis as well. So if we go into our next demo, which is just a streaming recommend streaming demo. So essentially this will just stream directly. So Drasi is not involved here. It's just a simple server sent events stream. So we're going to essentially go, right, I'll give some gift recommendations. So the child is given the child is age 0, because we didn't specify it. Here are the gift recommendations that celebrate their good behavior. So soft fabric activity, a book, musical play, gym, stackable soft blocks, sensory feeders, example. I know anyone watching this can see a breakdown in the logic there around age 0 and some recommendations, but it's all about what data that you give these models. In this scenario, in this example, it was literally just, let's send it a request. Let's not use Drasi to ground it on anything. Let's just send it directly to Microsoft Agent Framework and GPT-4o and see what comes back. And as we can see, we're not getting back as much actionable insights that can make it easy for Santa and the elves. The next scenario I'm going to show you is the naughty and nice behavior detection. So we've talked about this a couple of times. So for example, if we're querying what toys or what gifts to give children, it really depends on their behavior. So what I'm going to do here is we've got demo behavior 757 child. We're going to say, actually, you've been a bit naughty. You've been playing around in the sandbox, and you're not sharing with other children, so you're on the naughty list. So we're going to specify that you are currently naughty. So that will automatically trigger an event in Cosmos database, which then the change freeze as a Drasi source will get picked up. The continuous query will detect that for this child, actually you've gone from naughty to nice. The elf recommendation agent has then received that naughty status and then adjusted the gift criteria to match. So not only are you then being able to bring in what is the current trending items at the moment, what does the child actually want from wish lists, but you actually bring in other statuses. So are they naughty or nice as an example, and their behavior is set to naughty. So because of that, Microsoft Agent Framework and the elf agents have essentially gone, okay, based on your naughty status, you're now going to have an educational adventure kit, a science exploration kit, and kindness and character building blocks. So because the logic that I've gone is essentially because you're naughty, you get more educational gifts than you would get for fun gifts. So if we go back in here and we go to naughty or nice, and we go, actually, we now have a nice child. we can see here the same process trigger with the continuous change freeze and then Microsoft Agent Framework coming back. And we can see here that because we have a nice child, the recommendations are more fun. So the child is getting an Xbox Series X or a bicycle or a telescope. So these are things that are more fun and rewarding because you're nice. So you can see that information. So if we were to automatically change from naughty and nice, the recommendations would automatically get updated as well. So just a bit more on what Drasi is offering here. We're going to query the tools that have been built in. So these are tools that will connect to Drasi Signal R and API endpoints that are running on Azure Kubernetes service in this environment. But that is bringing in and grounding it on a lot of the actual information coming in at the moment. So we can query the trending items. So it's getting the most popular wish lists that are trending right now from child requests coming in. We can find children with duplicate wish lists. So you might have children that have the exact same item as an example. You might have children that have been inactive. So they haven't sent a letter to Santa, or they may be all grown up. How do we know that the child that potentially we have just delivered, a gift to today, may or has sent a letter to Santa in the last 5 years, have not sent one this year? So this gives us a logic to know what children either all grown up or haven't sent anything through. And then, of course, the behavior status of naughty or nice. So these are just a demo set of some of the queries that are built in Drasi and being able to create into tools that Microsoft Agent Framework is able to bring in and ground the data on live information. So the final demo of this before I run into the UI is just to prove that I haven't fabricated anything. I'm going to create a custom child. So in this example, my custom child will be, this is just the ID, so it just needs to be unique per child. I'm just going to just call it Luke. I'm going to specify the name as Luke. I'm going to specify the age, and I'll just 21. We're going to enter in wish list information. So one of the things that might come to mind is a skateboard. Okay, so this is creating my wish list that essentially is my letter to the North Pole to Santa, and then automatically the same process happens. So the events published to a Cosmos database change feed that then gets picked up by the Drasi continuous query. It updates the graph that actually we now have a new wish list event. Microsoft Agent Framework gets the elves busy and then comes back with the recommendations. So we can see here that the total recommendations coming back is a skateboard because you asked for a skateboard and this is a perfect match. It's made up for your age and skills, ensuring you have a blast. Obviously the skateboard helmet is a perfect match as well, since you've got your eyes on the skateboard, and so on and so on. So you can see how you can bring in a lot of live data and then instantly act on that with Microsoft Agent Framework and generative AI as well. So this gives you indication of some of the workflows that are happening in the back end. But if I'm Santa, I may want something more similar to this, where I've got a dashboard of what the trending items are, what the duplicate items that children have requested. So in this case, we've got child Emma 2025 has requested a PlayStation 5 over 1,000 times. So she really wants a PlayStation 5. We can see some changes with the naughty and nice status changes. So those keen eyes can actually see that these were the users, these were the children that we've just changed from naughty or nice. we've got our live notifications here. Again, from Drasi are over, new recommendations have been generated for children that have come into play. We've got our trends, so this is a bit, even though this is live from a Signal R reaction, this is more of your standard REST API endpoint, so this is more of a poll, which is why it's a bit out of date, because it's more intended for the logical view. If we were to come back here tomorrow, we would actually start to see some of this change based on the information coming in. What we can do is we can go into our Drasi agent tools and then just send some events. So this will send some random events that include wishlist items and behavior updates as well, which will trigger some changes and hopefully some more requests start to populate in here, and some naughty and nice changes as well. So that's 73, so we'll keep an eye on that. While that happens, what we can do is we can run the Drasi tools directly from this front end. So when we were talking earlier about the different queries, this is a view into the data that those queries have that's being directed to the front end. So we can see here that the query trending wishlist items, so this is a tool that Microsoft Agent Framework is calling, and we can see in the UI essentially is our popular items at the moment. So Lego Star Wars set has been requested 815 times. What we can actually see here as well with the query global wishlist duplicates is, even though the Lego Star Wars set has been requested 815 times, it's only been requested by 35 children. So we can see that one or more of those 35 children really wants a Lego Star Wars set, so they sent in more wish lists than needed. But we can use this data to get a clear view of kind of what inventories that we may need. So this is based on the wish list trending 1 hour query that's running, and then this one is wish list duplicates per children as well. And we don't have any inactive children at the moment, so this query is more around if there's a child that hasn't sent a wish list request in the last 3 days, they would appear here. So as you can imagine, you may have scenarios in Santa where they're all grown up, or maybe they've been too busy. We can see here that actually we've got a new child here. Child demo 03 is now appeared as nice based on the naughty nice stages, naughty or nice, and child Sophia has just appeared as naughty. What we can do here is we can go into child Sophia, like I'm Santa and I want to drill more into the gift recommendations per children, we can open that up by just selecting her under Santa controls. Then we can go to elf operations and we can actually query some of this stuff. So if we go to recommendations, we can see that now, very similar to the PowerShell demo experience I just showcased, we should be able to get recommendations based on what the child's asked for and their naughty or nice status. So Sophia is naughty, so we should be able to get more character building, brain teaser, puzzle set, mindfulness, activity journey, because she is now naughty. If we go to child demo 03, we can see here that the recommendations, because we now selected a different child, we get more fun things. So Nintendo Switch game bundle, giant teddy bear, because that child is nice, as an example. What I'll do as well is quickly go over back to my PowerShell demo, and I can go into my naughty or nice behavior, and I will select that one, Sophia's naughty, so I will select a nice, and we should be able to see a new child appear here. So demo behavior 7972 should now live appear here, based directly from Drasi and Signal R once that has gone through. And we can see here that now we've got a demo behavior 973, 972, sorry, now is nice. So that automatically came from the continuous query and Signal R. So this is all live as we speak. So that's a demo. Hopefully that's giving you a good understanding of kind of how Drasi and Microsoft Agent Framework can work together. I'll go back to the slides now and talk a bit more about some of the technical capability and technical things that make the solution work. So hopefully you've now seen in the demo that the child submits a wish list, the backend then publishes it to Event Hub, Drasi then detects certain patterns, so the wish list, naughty or nice, then updates and Signal R and the Cosmos database as well for persistence, and then AI agents can run based on the recommendations and ground based on the data coming back from Drasi. So let's talk a bit more about how this works. So it's crucial to understand that Drasi is not just running a query every time we ask. So the architecture is essentially you have a source, so in this case it's Event Hub, which is processing a change feed from Cosmos database, so that's a source. The second is continuous query engine, which essentially maintains a stateful index and cache results based on the data and the query matching that it has. Then you have your reactions, which in this case is Signal R, which is pushing the changes to the clients in real time based on the continuous query results. Dapper is used here as well, so for those familiar with it, like Drasi uses Dapper internally for communicating the sources with the query engines and also state as well. So it can be used, for example, to communicate to Cosmos database for Dazure state and pub sub reactions as well. We're not overly using Dapper here, but it is built into the Drasi engine and does a lot of it without me needing to touch anything. So the magic really is the incremental processing. So when a query starts, Drasi then bootstraps it by loading the initial data. It caches the query results in Redis or its memory. And then when new events arrive, it incrementally updates the results. So it doesn't need a full scan every single time a new entry comes in. It just needs to incrementally update those results. So for example, if the Lego Star Wars count goes from 44 to 45, Drasi doesn't need to recount everything. It just increments that by one number. So for example, the item Lego Star Wars goes from 44 to 45 without having to reprocess it as well, which is why it's quite fast. Hopefully you've seen that in the demo. Essentially, actually the longest time was Microsoft Agent Framework, going through the agents, calling generative AI as well. It's one thing worth a note about the solution is that this was all developed within the context of a development environment as well. We'll go a bit more into the architecture, but I didn't really scale up Azure OpenAI. I didn't really worry about having Azure API management, for example, or semantic caching. It was literally just, here's an Azure OpenAI endpoint, connect Microsoft Agent Framework to the endpoint, and go for your life. Just a bit more about Drasi as well. Like Drasi can serve data in two different ways. So you've got your View API, which is what we were using. Essentially, it's a pull pattern. And this is some of the information where, like I might have talked about, you've got your old historical data from 2005. It is 2005, but from 2004, and then you may want to match it up with data or trending data from 2024 for an example, but I don't need that live. So in that scenario, I'm using the View API, which is just a pull. So each continuous query will expose a HTTP REST endpoint. The AI agents then call that on demand when they need it. And so does the front end as well. So there's no persistent connections happening here. It's just a get on the data when we need it the most, which is why it was not essentially live and updated. But for all that live view, so the naughty or nice and the trending statuses that we've seen before, it is using Signal, and that's a push pattern. So it's like a WebSocket hub that pushes events when patterns change. So instead of the pull, which is the view API, this is more of a push, which is the front end then subscribes to. So you get instant notifications as well. So an example of this would be Drasi detects that Lego Star Wars is now trending at 1, so it pushes to all connected clients without needing to pull. So why would you use both of these patterns? So agents don't really need a push. They query on demand when the users ask a question. So this is a traditional generative AI transformer model scenario where you've got a chatbot or you're talking to it and you want a question. That it doesn't need a pull for that information. It just needs to push when it needs that information and ground it. However, something like a front end, for example, like our Santa dashboard, may need a push. So users want to see live updates without refreshing based on the current data and the current scenarios from those continuous queries. So different access patterns have different needs. I'm using both in this context. So SignalR is really the driver of the solution, being able to see all that data coming in nice. So the naughty and nice status changes, for example, and then the view service and REST API get requests more for the historical data because we don't need those live. So that's Drasi. So to the AI side, we'll just talk a bit more about Microsoft Agent Framework. So this was built on .NET. So it was built on .NET 9. I did upgrade it to 10 and it all worked perfectly, but I just downgraded it to 9 because I was jumping around different computers trying to develop this, and version 9 was the one that was just on both of them. So it made easier, instead of with the time limit of trying to get this out for the festive tech calendar, to just keep it on version 9. But I did upgrade it to 10 using the GitHub Copilot app modernization and compatibility capability, which was showcased in Ignite, and it all worked reasonably fast and reasonably well. So just going back to Agent Framework again, like it just lets us build AI agents that can call tools and work together in workflows. Think of it as giving your AI access to functions and APIs in a standardized way. So this was a mix of semantic kernel and a bunch of other tools as well, where Microsoft has now standardized on Agent Framework to do that. So the code that you can see here is creating our behavior analyst agent. So notice the instructions tell it exactly what tools to use and when. So the magic is when you call the agent, it will automatically decide which tools to call based on the task. So you don't have to manually orchestrate it. The LLM figures it out. It's bittersweet, this one. It took me a lot of times and a lot of prompt engineering to kind of always get it to call the tools that you need or expect it to call, for example. It's one of those things that we're just working out with deterministic solutions, but in this case, very, very specific around analyze child behavior, recommend gifts, and then use the tools that have been built in to request access and ground the data as well. So you have to be very specific and don't over-engineer these prompts. We were using sort of the preview packages because I don't think it's 1.0 Microsoft Agent Framework yet, but it all worked fine. Tool calling, yeah, as you can see, worked wonders and was able to hit the SignalR endpoints and do those GET requests from Drasi as well. Just a note on the UI layer, so this is the Santa dashboard that we showcased as well. This was using the AG UI implementation or framework. Essentially, that just allowed us to execute in a standardized way a protocol that was doing things with events that were built in. So run started, we could see like messages and context coming in. When it was in the logs, we could see when the tool was called, when it was finished, as an example, the Drasi context was passed into a context array, and the backend was able to extract it. So it worked really well as a protocol to essentially bring those in, and then the front end operated in that standard way as well. It's something up and coming and quite popular at the moment, because especially with MCP server support and different chatbot frameworks and ways of communicating as well, being able to have a standardized way of being able to bring in some of the agentic capabilities from a UI perspective is quite helpful. So I definitely didn't use this to the full extent, but I did use AGUI and Copilot Kit in order to develop that front end, to really wrap it around. Let's take a look at the next thing. Is some of the frameworks I followed. So I just want to highlight it because it's important. So this wasn't just a quick demo hack. I actually tried to follow real engineering standards when I developed this. So one of the standards that we're using is the Microsoft Industry Solutions Engineering Playbook. So this is the ISE Engineering Playbook. And that includes recommendations from the ICE team around how you would do CI/CD testing, security, observability. So I definitely took that in mind when creating this. Is basically what are the best recommendations coming from the Microsoft Industry Solution Engineering team, and how do I adhere to those when I'm developing this as well. The other thing that I followed was actually Microsoft's API guidelines for Azure and the REST API design. So I used that when I was looking at how do I architect the endpoints that these are connecting to. So we have our front end, but we need our API endpoints as well. So I followed some of the best practices from the API guidelines for this. Now, as you can see here, so URL versioning, status codes, e-tags support to know when things have changed, error handling, cause, and health endpoints as well. So this was something that I learnt from reading the documentations. Is in previous solutions that I've developed, always the health endpoint would be something like /health. But there's a difference between domain and business logic. So for example, one of the recommendations was actually the health endpoints would end with a Z, because they're more domain, they're infrastructure. You want to know if the infrastructure is not working, not necessarily what the business logic is. So that's where there's a difference. So you might have both a /health Z endpoint for the domain, the infrastructure layer, and then you /health for more of your business logic processes as well. So that was definitely a learning for me. But definitely when looking at building and testing solutions, the ICE playbook is really helpful as well. It gave me a lot of recommendations around some of the script analyzers to use to make sure that my .NET project was able to build without errors and align to best practices as well. So just touching a bit more around the top two tools. So this was Drasi on 0.10.0. So Drasi handled all the continuous queries, and then Microsoft Agent Framework would then connect to that as well. So as you hopefully saw in the demos, they both work side to side together, where Drasi detected the patterns and the agents were able to bring in generative AI magic to those patterns as well from the perspective of the center. So just a logical architecture flow is what was happening is you have a front end, and in this example we had our center front end, or we had the PowerShell script which was able to send a request. So that sent a request to the REST API. The API then writes to Cosmos database, so it's received a letter from Center and it's filed into the mailroom. It then publishes an event to the Event Hub. So these are as wish list events. Drasi then subscribes to those events and runs its queries. So when the patterns match, so things like trending items, duplicates, behavior changes, Drasi then sends the real-time notifications to Signal R, and then AI agents can then query Drasi or respond to those notifications as well. So it's just a key point. everything's happening in real time from event to notification. So it's a bit under 5 seconds for Drasi to really process those events. Really, in my mind, quite quick. The slowdown was really with trying to get the agents to work as close as possible. So I tried a few things around sequential versus async patterns just to see whether or not we could get it giving data back as quickly as possible. Otherwise, we would have spent the demo waiting for the answer. Like I said, this wasn't built with things like semantic caching and things like that. It was more of a, let's do something cool for the festive tech calendar here. So that's a logical behavior of how it works. The backend, the infrastructure layer, Azure Container Apps is running the front end and the back end. I did originally start this with the front end being on Azure Static Web Apps and the back end being Container Apps, and then having the back end linked to Static Web Apps. But I ran into problems because Static Web Apps linked backend didn't support WebSocket support, which we needed for Signal R. So one of the workaround, and I didn't, because we're also running Drasi in an AKS cluster, I wanted to try and keep that solution separate because I was working on the continuous queries and trying to get the logic and the syntax of those right. So what I end up doing is simplifying it by actually having Container Apps hold the host end and then the back end as well. Then the database is Azure Cosmos Database, so that's just a NoSQL that's doing our event streaming for us. So we've got event hubs picking that up. Drasi, of course, running on AKS, version 0.10.0, as I talked about as well. And then Signal R service, Azure Signal R also. So that was running on the AKS cluster as well. So I didn't need an additional service for that. And then Azure OpenAI running GPT-4o. So everything was secure with a key vault, but most things were just connected with managed identity support as well. And no VMs to batch in this solution, all PaaS powered resources. It was a lot of fun to play with actually. So let's just break down kind of how the Drasi queries were working and how it hopefully can add a bit more context to what you saw. So this is a Cypher query that was in use for the change request that was monitoring the wishlist events from the Cosmos database source. So we've got a match that finds any wishlist event, so that's any event that's hitting the event stream, where within the last 30 minutes, it will then filter it based on a request type of gift. In this case, we could have another one as well with behavior, so naughty and nice, and we do, but this one is just gift, and then return the items by the item count and count their frequency. So the query run in Drasi runs continuously, so it just bootstraps it by processing existing events that were already in the database to begin with, or already in the change feed, and then it counts in its cache, in its stateful cache that it has, and so as new event arrives, it automatically updates, so it can go back to all the current ones that were existing and incrementally increase them as it comes on. So it's able to catch up. So in this example, again, just to reiterate, when a child requests Lego Star Wars as an example, the event arrives in Event Hub. Drasi source then reads it within seconds. The query engine then updates Lego Star Wars. The count goes from 44 to 45. The cache results are updated, then the Signal R pushes us out. So there was really no polling a lot in the solution. So just some information on the data. So we got sub-second latency from the event to detection, live action, live updates to our Signal R WebSockets. Trending items was for the last 60 minutes. we added some smart duplicate detection as well. So things like Lego Star Wars, so Lego in capital letters and Lego Star Wars were all detected as being duplicate items and then merged together. So it really worked. And it's in this example, like when I ran this yesterday, the top items were like Lego Star Wars, Nintendo Switch, Harry Potter book collection, remote control car. So if you saw in the historical data about like Harry Potter book collection, but then we didn't see any of that in our demo today, we can see that that's actually, like tomorrow, that historical event should update with a lot more of the Lego Star Wars and the PlayStation 5s that children have wanted. So I'll just go into Microsoft Agent Framework and one of the tools. So this is how we created our tool. So we had sort of two types of tools. One was our traditional tools of querying the Cosmos database. So this was querying information on the wish list items that were added to the Cosmos database. Then we had our other tools like from Drasi, so they were the real-time data. So just example is it hits the Drasi continuous query from like the trending items for the last 1 hour, and it returns them returns the items in the last 60 minutes. Things like Lego Star Wars requested 45 times, find children with duplicate wish lists. So these were a couple of different tools. So the traditional, let's call data source, so Cosmos database, and then the Drasi continuous query calls as well were both as tools. So just to touch again on the Drasi ones, so the Drasi queried the view API, so it was just a REST HTTP endpoint exposed by Drasi that matched the query and was able to give us the results. So we didn't need to query Cosmos database directly, but we could also use the tools to query both the Cosmos database for historical events and live data from those feeds if needed as well. And the agent decides which tools to call based on the task, based on the prompt, as we saw earlier. This is just an example of some of the things that we had to go through for actually getting the agents created. So one of the things is be very specific, I always say specific about what you're saying in the system prompt, because you're trusting this in some ways to be deterministic about what you're wanting out of it. So in this example, we knew that we had a behavior analyst elf that needed to know what the child requested. There could be a lot of variability in how the model and the type of model and the version of the model might call. So in this scenario, I was very specific to be like critical. Always call the get child wish list items first. That way, we know we could ground the information based on what the child actually wanted and not have to hallucinate it. So if you remember back to the demo when we just went that send a server, that streaming event demo, that wasn't grounded on anything. It had a whole lot of things about fluffy animals and stuff like that, but that wasn't grounded on the data and the wish list, the actual requests, or the trending data, or the behavior history of the child. So we just had to be very specific in our system prompts to Microsoft Agent Framework around, hey, we've got this behavior analyst agent as part of the things and the tools. Here's a couple of tools that you should be doing and the workflows that you should be operating in. And hopefully you saw that work really well in the demo today. This is just another example as well about how the tools, like the wish list item is being generated, and how it's returning as well. So essentially it's basing the recommendations based on the information coming back from the tool, and then it's also like base recommendations on these festive items as well as the Christmas wish list from the child as well. I'll just quickly go through it. one of the things that I was considering was kind of, do we really want to give children what they ask for? Usually in real life or production, the answer is no. It might be a mix of what they ask for versus what they need. It's a whole need versus want scenario. But in this example, we were just like, so when a child submits their wish list, those items then become the preferences that the Microsoft Agent Framework then uses for the recommendation. So if the child asks for an Xbox, the AI will recommend the Xbox, suggest related items like safety gear and like skating sessions or gear controllers, provide rationales that reference the interests that they have, because it just made the demo a lot more compelling than going, but again, like if we were to add a lot more data into the context, so we added a wish list item or a letter to Santa and went, this child aged this amount, this gender, wants this, give me recommendations based on current children in a similar age bracket, in a similar gender with this budget, the recommendations coming back would have been quite different. Just touching a bit, Drasi was really the key to making this work with its continuous queries. We had the three elves working together, so the behavior analyst one was analyzing the naughty or nice history. The creative elf was calling the gift inventory to find matching gifts, and then we had the quality reviewer elf calling like checking budget constraints, things like that. So each agent had a specific role and calls specific tools, so they really worked together to give a succinct answer and some recommendations that were quite useful. Again, naughty or nice, I think we showed this in the demo, but if you were nice, you would get things like fun, exciting, rewarding gifts. If you were naughty, you would get lumps of coal, like education materials, for example. The AI agent was able to adjust the recommendations based on their behavior history that was queried directly from Drasi as well. So just a bit more about kind of the performance metrics. So Drasi was giving us sub 5 seconds from event through to detection. Its query throughput could do over 1,000 events per second. Agent Framework was, had 3 to 8 seconds when I was using a single agent to recommend. When I was looking at a multi-agent flow, so those 3 elf agents, it did go up from 8 to 15 seconds, but I believe it made a huge difference in the quality of the output we were getting. The streaming rate was about 50 tokens per second. So if we were to do this at scale, the architecture could handle 10,000 concurrent children with over 100k letters per hour. So I think the streaming rate means that users can really see responses token by token without like needing to wait for the whole answer as well. So you can kind of work out how much this would cost you in the scale that you would need if you were to expand this out. Just like finishing on time, but essentially just recap. Hopefully you've seen sort of the power of Drasi and Microsoft Agent Framework, but the pattern's just not for Santa. Like you could use it in other real world cases, so like cart abandonment detection. So the AI agent could reach out with personalized offers or notifications of like carts are being abandoned, like dynamic inventory optimization, market trends, quality controls, So it's really, the pattern's really about what the event is, what is the pattern detection, and what the intelligent response is that you're looking for. So key takeaways: Drasi, really useful with Cypher queries. Just a note, it does not support all Cypher query syntax. I ran into that quite a few times, but the product team are improving upon it, which is really great. And then multi-agent AI orchestration through Microsoft Agent Framework, and try and develop using like engineering practices like the ICE engineering playbook and Microsoft API guidelines, for example, as a base when you're building these things from the get-go. And then you know if you need to scale it from a proof of concept or proof of technology into production, you've got a good sounding base. So don't just vibe code this. Use technology that is at your disposal, and recommendations and industry best practices as well. Some lessons learned. So there were quite a few when I was building this. Like I said, it was a lot of fun. There is a difference with deploying the reactions and the queries and the sources. So I relied on the Drasi CLI a lot to try and deploy those items because it was essentially native. But there were a few cases where, for example, I needed to try and look at kubectl for custom resource definitions for Kubernetes, which didn't quite work well. So I tried to essentially create a lot of the manifests needed from scratch, and found out that actually going back to the native Drasi CLI tooling made things a lot better, because of some of the custom resource definitions for Drasi and some of the queries and sources weren't necessarily public facing, so I wasn't able to really pull those out to build on and develop that further. But yeah, I had huge amounts of problems switching between and trying to use kubectl. Just use the native Drasi CLI. I had issues with port forwarding. So when Drasi applies port forwarding to the API pod, if the pod isn't ready, it will fail with a lost connection. So there were a couple of times where I was like, it's not working, redeploy, readjust, delete the query, reapply the query, where the solution was really just to wait for the pod to be ready and retry a couple of times. So that just wait, give that pod a couple of minutes to really start. Don't just start. This whole thing I was able to deploy using AZD up, so it allowed me to tear down the environment and stand it up from scratch. In fact, I've got it in a public repo for you to run, and I'll share the repo with you shortly. But I had to add a lot of logic with PowerShell to essentially, okay, you're going to deploy Drasi using the Drasi CLI. Wait before you apply the source, before you apply the query. Check the syntax. There were issues with like the image registry double prefix as well. So when I was trying to use the manifests, they had the full registry path. So github.ch.io/Drasi project, for example. But then when we tried to use the Drasi CLI, it kept doubling up. And so I kept running into problems with pull back off failures and crashes of those pods, because it was trying to bring in images from registries that just didn't exist. Touched a bit on tool calling in the earlier. Just be very specific about what the instructions are that you want. I had some issues with, because I was originally planning on using Azure Static Web Apps, I had a lot of placeholder credentials that needed to be in place and then get overwritten as part of the build, because Azure Static Web Apps, essentially, once you build it, it has the environment variables. It's not something like Azure Functions or Azure App Service when you can actually change the environment variables live. Azure Static Web Apps is essentially, once it's built, it's built. So in order to change those variables, you would have to go back and rebuild them again. So I ran into problems early on, especially when I was using Azure Static Web App, that I needed to update some of the variables. Things like this is the AKS cluster IP for the Drasi tool calling, for example, or this is the endpoint for container apps. Those were things that needed to get created at build time, and so at deploy time, sorry. And so I had problems where some of the workarounds I did about injecting those endpoints into the Azure Static Web App build wasn't working. So I had to sort of work around that and think through that as well, because I needed to get that running, because when you deployed an AKS cluster, for example, in a container apps environment, it may not necessarily know what those are until they're deployed. So, and then I needed to inject that into the container apps front end to be able to read through it. So just have to think through logically around where these things are being created, and then I had placeholders so I could do the front end build successfully and then overwrite that as part of the deployment as well. So that required some PowerShell scripts with Azure up, AZD up, in order to do that. So just before we wrap up, this is part of a Festive Tech Calendar 2025 event. So this is just one of many awesome community sessions running. I hope you found my sessions useful today, but the Festive Tech Calendar is fundraising for the Beatson Cancer Charity. So Beatson provides services, funds, specialists, research and education for cancer patients. They support patients every day of the journey. So if you found this session useful, please consider donating. Every contribution makes a difference in people's lives. Also, make sure you check out the festivetechcalendar.com. The community leaders have done an amazing job organizing this, so thank you for allowing my session to be a part of. Definitely going to keep up with a lot of sessions happening at the moment, so we'll all learn anything. So that's it. Just a recap, Drasi, definitely take a look if you haven't seen it as well. I had no end of problems and fun playing around with Microsoft Agent Framework. Tool calling just made things a hell of a lot easier. Use the frameworks like the ICE, look up frameworks like how does Microsoft do APIs, for example, standards. What are some of the cloud patterns and application patterns that might be on the well-architected framework as an example? Take that into consideration when you're looking at building some of this stuff from the get-go, because it will help you expand and scale out the solution. So feel free to reach out to me on any social media if you have any questions. I'd love to see anything different. Don't forget the charity. Don't forget taking a look at the Festive Tech Calendar, and happy holidays. Hope you all have a good break away from the computer or gaming, even at the computer gaming. Just hope you all have a good chance to break, have a drink, have a Kit Kat. See you on the other side.